Looking at parallel lines cut by a transversal, really quickly, this is going to be a review. So anytime I have parallel lines being cut by a transversal, like we do over here on the right-hand side, line CD, line AB being cut by EF, you're going to create either one of two situations. The angles are either going to be supplementary, where they add to 180 degrees. Usually these are angles that create linear pairs, or consecutive interior angles, or they're going to be the same, equal, like alternate interior or alternate exterior angles. You just have to determine which is which. For instance, 1 through 4, we got to answer questions based on the values of our angles. For instance, we are told to find angle 5 when angle 3 is 80 degrees. So we know in our case, this angle here is going to be 80 degrees, and we just have to see what the relationship between angle 3 and angle 5 is. So I see angle 3 and 5 are on opposite sides of the transversal line, and they are both on the inside, so they are alternate interior angles. Alternate interior angles are equal, they are the same. So this means angle 5 is also equal to 80 degrees. For number 2, we have to figure out what 5 is when angle 3 is x and angle 4 is x plus 20. Well, in the previous problem, we already said that 5 is the alternate interior angle to 3, and they are the same. So this means angle 5 also has a value of x. The relationship between 4 and 5 is one right after the other on the same side of our transversal, and they are on the inside of our parallel lines. So these would be consecutive interior angles, and consecutive interior angles are supplementary. They add to 180. So if I were to add my two angles here, x plus 20, I'm going to get 180. And to solve for x, we have 2x plus 20 is 180. We subtract 20 from both sides, and we end up with 2x equals 160. We're going to divide by 2, so x is going to equal 80. So this is an instance where we have supplementary angles. And we can use the same relationship between problems 3 and 4. 5, 6 are relatively simple as well in terms of linear pair and using the angle relationships to figure out missing variables. 7 and 8 are a little bit different, in which case I give you a shape. We have two parallel lines noted by little arrows here. We need to figure out the value of x and y, and I will use number 7 as the example, since that is a little more involved. So 7 is going to be a little easier if we were to extend the line out a little bit. So here we have our parallel lines being cut by transversal. So notice here that we got two pairs of transversals. It really depends on what we're looking at. So if I want to take a look at our relationship between, say, 94 and 3y plus 44, parallel line cut by a transversal, well, what does it look like in this particular section? We have them on the same side of our transversal here on the inside. So they're consecutive interior angles. Consecutive interior are supplementary, so they are going to add to 180. So we really have 94 plus 3y plus 44 giving me 180. And I want to solve for y. So I'm going to add my like terms. 94 and 44 gives me 138, plus 3y gives me 180. I want to subtract 138 from both sides. So I get 3y equals 42. And I'm going to divide by 3. and y is equal to 14. So we figured out what y is equal to. And now we need to figure out what x is. So again, I take a look up here. We have two parallel lines being cut by a transversal, and the same relationship is going on between the 96 and the 2x. They're on the inside of our parallel lines, and they're below the transversal. So if I add them up, 96 plus 2x, I'm going to get 180. So I'm going to subtract 96, and I get 2x equals 84. And when I divide by 2, I get x equals 42. And we can do the same thing with the other problems. 9 would deal with factoring a quadratic equation. 10, we have to draw the auxiliary lines. I'll do 10 real quick because 11 will be the same. Auxiliary line, again, is a kind of a imaginary line that we draw through that point right there where the 72 is. And what happens is this line is parallel to the other two lines as well. And we can use our angle relationships in order to figure things out. So if this part is x, because we have a vertical angle here, that's also x. And on the inside here, parallel line cut by transversal, this angle here is also x. And now we know this part is 72, but again, down here below, 50, we know with vertical angle, this angle here is 50 degrees. And again, parallel line cut by a transversal, this part down here is worth 50. So if the whole angle is 72 degrees, I have to add 50 and x to get 72. So subtract 50, and we get an x value of 22. So we found the value of x, we're good to go. And then 11 would be the same way, and that is just a review on parallel lines cut by a transversal.